Ladies and gentlemen, a very warm welcome to our IGZ channel Innovation at Work. Our topic of today is Next Level MES, how SAP Digital Manufacturing Cloud takes your production to the next level. My name is Andreas Busch and I'm the head of sales for SAP Manufacturing at IGZ. Well, before we get into the presentation, I would like to give you a brief overview about this session. At the beginning, I want to give you a short introduction of IGZ. Afterwards, my colleague Torben Petersen will classify manufacturing execution systems and answer the question of what is meant by cloud computing and software as a service. He will then introduce selected functions of SAP Manufacturing Cloud. Finally, I will present how to get ready for SAP DMC project. Of course, you are welcome to send us your questions via chat. We are pleased to answer them after the webinar. Okay, at first a short introduction of IGZ. As the name promises, we are not just SAP consultants, much more we are technical SAP engineers with a high level of technical integration and solution expertise for production and logistics. Meanwhile, we are 550 employees at our headquarters in Falkenberg, which is shown on this picture. Well, what is the mission of IGZ? The mission of IGZ is to perform the entire digital supply chain, from production to logistics and transport, with SAP Standardsoftware. This is reflected in the 4 areas of competences, which I would like to introduce you briefly. In the competence area, SAP Manufacturing, we support our customers in increasing the efficiency of production, improving traceability, and ensuring reliable process control by means of integrating the production systems and machines of the shop floor. The competence area SAP Warehousing supports our customers with warehouse management and material flow systems. The focus of the competence area SAP Transportation is the optimization of route planning, dispatch, and control and loading. And last but not least, our general contractor services with SAP Automation. This means we plan and realize complete logistics centers as a general contractor. Furthermore, we carry out retrofits of existing logistics systems and have a high level of expertise in control technology and our own control cabinet production. Therefore, in total, as already mentioned, we realize the full digital supply chain for our business. Okay, let's have a short look to some of our references in the field of manufacturing. As you see, we cover a wide range of well-known companies within the discrete and process industry. Okay, so far to IGZ. Now the question, what is cloud computing and what is software as a service? Before we answer these questions, I would like to summarize what is a manufacturing execution system, in short, MES. A MES is an executive independent system for production control. It ensures consistent vertical integration between ERP, MES and the shop floor, and thus allows effective company processes. The MES enables a digital order processing, collects data from the machines, and ensures online transparency during the entire operational production process. The MES can be perfectly adapted to the processes of the respective production scenarios. In total, by means of a manufacturing execution system, production costs can be reduced and the effectiveness of your production can be increased. Now we would like to address the terms on-premise and cloud computing and distinguish between these 2 usage models. At the classic on-premise model, the required resources such as server, storage space, database and software are all provided by a local data center or own servers at site. Consequently, the MES software is installed at servers at site or hosted by a data center. The systems are operated and maintained by the companies itself in case of own servers or by outsourced data centers. By using cloud computing, all computing resources are provided via an internet connection to the cloud, enabling companies to obtain software systems, in our case the MES, independent from the site location from an external service cloud provider. The basic idea behind is that companies can largely outsource local IT infrastructures and have the required computing resources provided as service by a central data center of a cloud provider, depending on the actual demand. Okay, what this service of a cloud provider includes depends on the respective usage model. For this purpose, I would like to compare the on-premise model with the two models, infrastructure as a service and software as a service. With an on-premise model, users purchase the MES software by paying a license fee for the MES and operate the solution independently in a local data center of the company. In order to reduce acquisition costs for IT hardware and save corresponding operating costs for maintenance, there is the option of operating the MES software in a rented server of a third-party data center. In this case, the IT infrastructure of an external service provider is used and is therefore referred to as infrastructure as a service, the simplest form of cloud computing. This model usually includes the physical data center, all network and security issues, as well as servers and storage space. Which software applications, development tools, and operating systems run on the IT infrastructure you rent is still your own responsibility. Whereas with the software as a service concept, the user receives a full service package. The software provider manages all tasks from infrastructure to the actual software applications. The software license is in this case replaced by a monthly service fee, which is usually based on the actual consumption, which means users and resources respectively. Well, let us summarize the advantages of a software as a service model in the production environment. By outsourcing the hosting, support, security and maintenance of the IT infrastructure to an external service provider, you save a lot of time and can concentrate more on your own actual core competencies. At the same time, you relieve your IT staff and administrative tasks to give them more room to implement strategically important projects like MES. In addition, you save high investment costs for hardware and IT infrastructure. Through the external provision of almost unlimited computer power, depending on your actual needs, you're independent from the local capacity limits of your data centers and thus gain significant flexibility. Furthermore, you can easily activate access for additional locations without the need for a local installation of the software. This is a big advantage for fast and flexible global rollouts. In terms of license costs, you only pay for the users' respective resources which are currently using the MES. Another advantage of the software as a service model is that you can always use the latest version of the software, as the software will be regularly updated by the software provider. As a user, you thus benefit from the continuous further developments of the solution, in your case the MES. Finally, yet importantly, the cloud technology allows you an increased degree of mobility. As you only need an active internet connection to use the software, you can access the system from almost anywhere. Now I would like to hand over to my colleague Torben, who will introduce the next level MES of SAP, the Digital Manufacturing Cloud. Torben, please, it's your turn.
Thanks, Andreas. We will start with the system architecture and the SAP solution portfolio before we go into the main function of the DMC. Okay, let's take a look at the system architecture. As shown in the system diagram, SAP offers the perfect vertical integration between the ERP system, whether it's the ECC or S4, and the shop floor. SAP provides the digital manufacturing cloud in the AWS from Amazon or the Azure cloud from Microsoft. The operation platform for the DMC is the SAP Business Technology Platform, a cloud platform on which companies can book and use different services and functions, including the digital manufacturing cloud. The DMC consists of two central modules. The DMC execution, the solution for production controls, both of discrete manufacturing and process industry. And the DMC Insight, it's all about evaluations, analytics, and KPIs to make the performance of your production visible in order to optimize it. Well, but how does the data actually get from your shop floor to the cloud? At the top, we see the DMC, which a user with an active internet connection accesses from his PC or via a mobile device. At the bottom is the shop floor level, which brings together all the machines, production facilities, and assembly stations in your plant. In order to access the generated data of the local machines and to be able to send data to the machines, the established software component Plant Connectivity, or PICO for short, is used analog on the on-premise environment. This allows machines to be connected bidirectionally via OPC UA to the MES. To ensure the security of the communication from DMC to your shop floor, a so-called cloud connector is used. This acts as a secure connection between the cloud and your network and ensure a protected data transfer. Let's talk about how to ensure the production capability if there are limitations in the local internet connection. Reasons for this can temporary outages, limited bandwidth, or temporarily higher latency. In this case, communication between the digital manufacturing cloud and the local shop floor or DMC user would be delayed or possible temporarily interrupted. To avoid this potential risk and to improve the resilience of your production, you have the option to placing an edge device locally. In order to keep the scope of this edge device as small as possible, only production-critical applications are activated that need to give feedback to the shop floor within the shortest possible time in order to be able to continue production seamlessly. Well, but what about the other application? All other applications are still operated in the DMC and updated accordingly as soon as a connection is re-established. The edge component can be described as a security solution that is provided by a provider in order to ensure its production capability even in an emergency. Now you know what the system landscape around the DMC looks like, which modules is made up of, and how the MES solution can communicate with your shop floor. In addition, you have seen that even in an event of limited cloud connection, your data are protected and the production process can continue. So the basic has been laid. Let's take a look at what the DMC offers in the terms of content. What are the main functions? From our extensive cross-industry project experience, we naturally know the requirements of a modern MES and the resulting challenges for companies. Let's look at a selection of functions that the DMC currently provides. We start with a look at the digital manufacturing cloud for execution. This takes over production-related tasks of the MES. It is the basis for horizontal integration of the machines, control the correct order execution, monitors all production processes, and handle efficient resource and order management on the shop floor level. I would like to start with a central topic in the context of Industry 4.0, the reduction of paper handling. This holds great potential for companies. Several thousand euros can be saved quickly. To support this, you can configure your worker terminals, also called production operator dashboards, POD, by yourself. This allows to provide your employees with this information they really need. This means, for example, that there is no need for order slips or drawing in paper. In addition, you can also use the worker terminals to announce production orders, to start useful preparations if necessary. So you can actively use your existing data to control your production. The topic of quality. Today, ensuring a consistent level of quality in the production is not only a challenge, but also a success factor in the competition with lower cost producers. Process interlocking ensure that you achieve the quality target that you set. If compromises define rules that start, stop, or continue a production process. It is part of the digital data processing along the entire production and serves as a step to a zero defect production. Another important function is the fine order control and staff scheduling, which in DMC is called RIO for resource orchestration. The production manager can use this scheduling and shift planning tool to control and monitor what is happening in the production. With this, it is possible to AI support fills the gaps in scheduling in order to minimize downtimes. Production or shift manager can make final adjustments and optimization directly on the shop floor with the help of graphical planning support. In this way, local expert knowledge can be used to react quickly and efficiently to unexpected events such as a failure of machines or employees. The production expert can therefore always have the last word. The overview helps to quickly visualize and identify availabilities and problems and to resolve them directly within the same view. Changes are immediately incorporated into the production plan and the staff will be informed accordingly. Staff scheduling is another important function in RIO. This supports the production planner in planning staff based on production-relevant qualifications of the respective employees. Let's move from the scheduling of order to the actual production processes. Production processes define the interaction between machines or rules, action and workflows that control execution on the shop floor. The production process designer helps you to model production processes and creates transparency by creating the layout of a production hall. It is therefore possible to model your production process visually, link them logically, and adapt them to changing environmental conditions without requiring any programming knowledge. Well, we have already explained how the shop floor, machine and plants can be connected to the cloud. At this point, we will briefly summarize once again. As in the on-premise solution, the SAP plant connectivity, SAP Pico for short, data and interface concentrator is used between the shop floor and the DMC. SAP Pico integrates the machines of the shop floor with the SAP Digital Manufacturing Cloud via a cloud connector. The main applications are direct machine connection, automatic recording of machine statuses, capture and storage of process data. It is also possible to send process parameters, production programs, or setting parameters to the machines. This allows data to exchange directly and performantly between the machines and DMC bidirectionally online. Now, the Digital Manufacturing Cloud for Insights, DMCI for short. The task of DMCI is a centralized cross-site performance management. For this, it integrates data from SAP and non-SAP solutions, as well as different production and automation systems. It can be used to record, provide and visualize uniform key performance indicators in real time. The insights gained in this way are the basis for decisions to improve manufacturing performance, which are based on a global and transparent data foundation. The basis for implementing measures for continued process improvement. Let's have a look at the first example. The competitiveness of our production depends on many factors. Lean processes, low inventories, optimal utilization and availability of machines and short lead times are daily challenges. To manage these, key performance indicators, so-called KPIs, are necessary. These performance indicators can be used to manage the performance and activities in companies. Depending on the production area, different KPIs are relevant for measuring. For example, your production employee is interested in different KPIs than the production manager or the management, and the production foreman is interested in different KPIs than, for example, the production-related logistics. With the KPI builder in DMCI, you can now define the KPIs relevant for the different business areas from the data you have recorded and generate them at the desired time. In order to visualize these KPIs in a user-friendly way and adapt it to the respective environment, the dashboard designer in SAP DMCI helps you to display interactive manufacturing dashboards via drag and drop for a variety of business and operational data, such as the shop floor automation tags, warnings, critical situations, or the normal operation of plant in process. It also allows you to react in case of values do not correspond on your specifications. One of the most important KPIs is certainly the OEE, overall equipment effectiveness. The automatic recording of KPIs such as OEE allows conclusion to be drawing about availability, performance, or utilization and quality at any time. The OEE is therefore one of the meaningful KPI for the shop floor. DMCI offer you two corresponding possibilities to form your OEE, to use it as a production-related KPI, and to visualize it in a user-oriented way. In the event of deviations from the specified values, the DMCI also helps you to carry out a root cause analysis. This means that your production can be back on track as quickly as possible. Furthermore, predictive functions, which are based on historical and real-time data, can help your business to be more productive. Based on this, the question, what will happen then, can be answered. Let's have a look to follow an example in the area of productive maintenance. Through historical and real-time data from DMC, you can generate an adapted maintenance plan in Insights depending on the status, the utilization, and the knowledge of the planned orders, which will reduce quality defects and unplanned downtimes. Your data is used to save costs and increase productivity. So you see, SAP DMC helps you to be more effective and productive. Of course, this was only a selection of some main functions. Anyone who has followed the development progress of DMC over the past years know that a large number of functions have been added there at an impressive speed. And this will continue to be the case. So, how do you get ready for the DMC project?
That's a good question, Torben. For such a complex project like the implementation of a manufacturing execution system, it's of prime importance to carefully prepare the project in a discover phase. Well, how do we carry out this discover phase? Based on our long-term experience, following deployment analyses have been established over years. First of all, we jointly define the scope of the feasibility study in terms of an initial pilot project, which will be representative for most of your processes and will be the basis for the rollout of the MES solution. The second step is the to-be analysis, where we jointly compare your current processes with your desired target requirements. This also includes a classification of whether a requirement is optional or absolutely necessary. In the next step, the implementation analysis, a suitable solution approach, is developed for each requirement. In this context, we also procure a fit gap, respectively fit to standard analysis, and keeps the roadmap of the DMC into account. Furthermore, we will decide which system is responsible for which task. The result of the deployment analysis are a rough concept for the migration and implementation strategy, a rough time schedule, as well as estimation of the project budget, or in other words, how does it work, how long does it take, and how much does it cost. Finally, results are summarized in a management presentation in order to provide you all necessary information for the decision on the implementation of your MES project. Ladies and gentlemen, that's it for the session. We would be very happy to support you for the digitalization of your production based on SAP Standardsoftware.
We are looking forward to hearing from you. Thank you very much. See you and goodbye.